They should have said the poet. The poet. They should have said the poet. The poet.
Sending poets.
This is Sending Poets, a podcast about ideas. Our goal is to understand metaphorical truths within the beauty we find in the human experience. My name is John. With me is Bob and Tucker. What's up, fellas?
What's up?
We are wrapping up our three-body problem combos with a three-body solution. So to start, I just wanted to share a fun note. I've been watching the Chinese show. Tencent is the production company, I believe. But after last week's episode, we talked about the Roche limit. And so this week, as I was watching, it was in episode 20. Oh, they mentioned the Roche limit. It was very neat that came in directly into the episode. It was talking about how the Trisolarian planet experienced the Great Rip, is what they call it in the show, where a chunk of the planet was ripped away and became a moon because of this stacked gravity syzygy thing. So I thought that was really interesting. And I was curious, Bob, because you got through the first audiobook, maybe the second one now even, but do you remember the Great Rip? Was that a part of the books?
Yeah, I believe it was.
Yeah.
And it's not, I would say the part that it separates from the show, at least the Netflix show, was more about the virtual reality side. How it was handled was much more advanced or updated, if you will, from the network's Netflix production compared to how it was portrayed in the novel form. So I think there's many plot points that were you could recognize the plot point, but it was re-envisioned usually with an updated technology or updated character. So more characters, different characters, but like mainline points, like this thing happened in the virtual reality, portion of the game, so to speak. A lot of that stuff held true.
Interesting. Speaking of the virtual reality game thing, one difference between the Tencent show and the Netflix show, Netflix, the importance of this simulation being indistinguishable from reality is there. Everybody's so amazed, like this technology doesn't exist. In the Tencent show, the VR game, it's clearly like CGI. It doesn't.
Yeah.
And so that was really interesting.
It's like a haptic suit. It's like a haptic suit.
Yeah, right. Exactly. He's on an Omni treadmill kind of thing.
Correct.
Gloves. It's not just a, I thought it was a very artistic and interesting choice for Netflix to be like, instead of doing all that, like, why don't we just have this like shiny helmet thing that's, technology that we don't, have, and it works really well. I love how Netflix did that. Especially we've talked about this too. The when someone puts on the helmet and they show their eyes and they merge into like a single eye, a third eye, maybe. I thought that was really neat. Yeah.
See, and I want to bring up one thing about that whole the technology as presented by Netflix. That is terrifying to me. Because if they had that kind of control over, you put this helmet on and it becomes absolutely indistinguishable from reality, how do you ever know that you took that helmet off?
Ooh. Yeah, right.
Because
right.
they could they're in your head at that point. They could make you think that you did and then present to you an altered reality of your life, and you would never know.
Yeah.
Real quick tangent off of that to springboard. That's, I believe, John, one of the short stories in that egg collection. Is it not that you get? Am I right? Where you get into? No. I think I am misrecalling now. I think it is part of. Is it?
There's definitely something that's on the fringe of my memory about this kind of scenario where, and because I was about to say, is it the 13th Floor, the movie The 13th Floor, which is similar simulated reality type of story, where it's this simulation inside a simulation kind of a thing happens. Yeah, it is terrifying, Tucker.
It was in that book. I remember, right, because they're inside a virtual reality, and once you get to the point of the game creator talks to you, he tells you can't leave or something like that, right? Wasn't that part of it where you can't leave? I can't remember. Anyway,
yeah, I will have to go back through. I mean, it's again, good plug for Andy Weir in general, but The Egg on Audible, it's like an hour long. It's 10 short stories or something. Some of them are 5 minutes long. It's well worth it. Highly recommend it. Yeah, I'll go back through that because I can't quite remember a simulation theory, simulated reality story.
Yeah, you're like leveling up, and then there was one kid who got the pre-release, and then he was meeting a new guy in the game, and the guy was following him around because he's showing him this is what you do. Something like that. I can't remember where I heard it from, but
it does sound vaguely familiar. Yeah. Good stuff. So real quick, back to the Roche limit. Tucker, you also mentioned, last week we talked about the tides and the sun, or the moon and everything. You said you'd kind of had some follow up there. You wanted to go through
too. And I had kind of clearly known this in the back of my head somewhere, and I looked it up while we were talking about other things later in that episode. But the sun also affects tides, and granted, the sun is much larger, but it's much further away. So it's basically the sun has about half as much effect as the moon does on our tides. But what you have is when you have an alignment where the sun and the moon are in line with the earth, you have what's called spring tides, which is an exceptionally high tide. And then when you have the sun and the moon at like right angles, is called a neap tide, I believe, where it's the effects kind of cancel each other out, and you have exceptionally low tides. Now, an amazing, synchronicity type of thing that's happened to us several times. There was an article released this week where they found out that Mars has a 2.4 million year cycle with Earth that affects deep ocean currents.
Wow. When is the next round of that coming up?
That I don't know. I think it's a just much slower process, clearly, because it's on a 2.4 million year cycle. But
sure,
yeah, I mean it's crazy. So yeah, our next closest neighbor, which is much smaller than the sun and not as far away, also affects oceans on Earth. Crazy,
fascinating. Yeah.
Well, it's like almost so cool. in my mind's eye, I see clockwork with different different diameter cogs, and as these things, you guys can obviously visualize, as these things line up every once in a while. That's the beauty of the gravitational effect, is it's additive, right? This is the whole point of the three suns line up, and each one is piggybacking on the other one's force. And you can end up with these wildly inflated effects because everything is adding on everything else through each other. Whereas the light from the one sun behind the next sun, that's blocked, etc. Right? And so the additive effect can be profound, even on the million-year scale.
Well, it's we have the whole near Earth object asteroid tracking program, which is a good idea. Like, it's good, and it misses a lot of shit that it probably should catch. But you have alignments where the normally stable orbit of the the Oort cloud of asteroids, you get a planetary alignment and it tugs one of those out of that orbit. And now you have another new factor to
like
look
a Halley's
for.
Comet, right? You get like a Halley's Comet. One of these things gets pulled out in some weird, elliptical journey, and it's 77 years or whatever. I can't remember Halley's Comet, but it's something like that. And then also to piggyback, people look often, Drake equation kind of things. Where is the intelligent life? One of the things I think we look at is where we're at in our distance relative to the sun, the Goldilocks zone, and we have water. It's a rocky planet. But one of the other things is we have Jupiter. And, in our deep history, the ability for a Goldilocks zone planet to evolve a stable environment to have life evolve up to intelligence might also depend on having this giant neighbor out past us, right? This gas giant that's almost a star, and it's pulling a bunch of disruptive material out of our potential orbit. So, one of the things of looking for in the billions of galaxies and the billions of stars in each galaxy, looking for something similar to us to examine as, does it have life or intelligent life, might not be so simple. If we need a Jupiter type gas giant in our solar system, or in their solar system, excuse me, in order to create a stable environment for the rocky closer planets.
That's interesting. I hadn't thought about it that way before. Wow.
Yeah, we probably wouldn't be here without Jupiter.
Yeah, it's a big sponge. It's a gravitational sponge.
10-4.
I like that. Yeah. Well, speaking of huge things and stars, another piece we wanted to talk about is in the Netflix show. I haven't got to the episode in the 10-cent show, but I think it's coming. I think it's towards the end of the 30 episode arc. But actually, I take that back. In one of the first episodes, there's a brief moment where, just like in the Netflix show, the base, the Chinese base where they're broadcasting signals, somebody points the satellite dish at the sun in order to boost the radio signal. And I was curious, is this real? So I did some Googling, and I did find a link to ScienceDirect.com article that goes through some stuff that's way over my head, but it sounds like it's potentially, so there's some real science there. But what I really wanted to spend a little bit of time talking about was this Reddit post that was asking the same question, and I'll put these links in the show notes. But what's so interesting is the top comments are all just, this is fiction, there's no basis in reality, obviously this is science fiction, this isn't real. And then there's this brilliant comment by this brilliant username, Diet69 Dr. 420 Pepper. Bravo on the username. Anyway, and it I'll just read some of this. It says, to the commenters stating matter-of-factly that this has no basis in reality, how many of you study astronomy or astrophysics as a career? And then they say there's a certain effect of whose plot you do not want to be on the left side of, and that whole sentence is linked to the Wikipedia article on the Dunning-Kruger effect, which I've heard about, but I hadn't really looked into. And I just think that's this Dunning-Kruger effect is just so prevalent in our society today. But I want to read this line from that Wikipedia article. If you're not aware, I think this one sentence kind of sums it up, and I'd love to hear you guys' thoughts on this. But it says, in popular culture, the Dunning-Kruger effect is often misunderstood as a claim about general overconfidence of people with low intelligence, instead of just specific overconfidence of people unskilled at a particular task. Seems kind of spot on to this whole thing of, how many times we see these, again, matter-of-fact statements of that's obviously not real from somebody whose profession isn't the subject matter they're commenting on. Last thing I'll say about this, and then I'd like to hear what you guys have to say, but it comes up a lot of time in TikTok lives where I see people debating the shape of the earth. And the flat earth arguments just seem to be very look outside, look at the horizon, it's flat, obviously it's flat. And they're like, oh my gosh, that just seems like such a poor argument. Anyway, so
Well, and this came up before Bob jumped on in the pregame chat, but I want it out there in the world. I do. This is important. You look at the whole Colin Kaepernick thing and him making a political statement during a football game and what that turned into, and the main talking point of a certain segment was just shut up and play the game. We don't pay you to talk about politics. We pay you to play the game. And I turn that right around and go, you work at Walmart. Nobody's paying you for your opinion, and
either.
yet you feel entitled to put it out there.
Yeah.
And the big point is, what your profession is doesn't mean that you are not allowed to have an opinion and voice that opinion about something.
Yeah.
You can't tell somebody else that you're a football player, so you're not allowed to have an opinion outside of football, because you saying that is you having an opinion outside of your profession. Like, we're
Yeah.
all entitled to discuss ideas and to make statements, and to that's huge. It is what we build societies on, is people are being able to express their opinions. Like,
Right.
it's hugely important.
To me, I think it's a call to just be thoughtful and prescriptive with your words. The quick easy thing is to just throw a quick comment on something. You're an idiot. You can't possibly do this. You're dumb. But to quote Dumbledore, right? Sometimes you have to decide between what's right and what's easy. That's the easy thing. Maybe the right thing is to think a little bit, like, is there a better way I can say, this is my opinion. I don't really know. This isn't my profession, but I seem to, think it might be this, whatever. Like, doesn't that seem like a much more productive way to express those opinions than just, you're an idiot. You don't know what you're talking about. Here's what it is. It seems so obvious, blah, blah, blah. You know what I mean?
Well, and I think about this often. My dad said to me many years ago, probably when I was being a screw up, he said, the easy thing in life is almost always not the right thing.
Nice.
Like, the
Very
big decisions
Dumbledore-esque.
are hard. Like, it's not usually the easy choice is not the right move.
Yeah.
And that's not always the case, but
Sure. Yeah. Yeah. Well
one
said.
of his pearls of wisdom that I try to keep in mind.
Yeah. Yeah.
Well,
That's awesome.
let me opine here two
Yeah,
quick
please.
ways. First one, to piggyback off of what Tucker was saying about, let me reframe it as, instead of as an individual episode of someone speaking their mind, whether they're expert or not. Let me put it another way, which would be the individual versus the group, and there's power in both. Okay, there's a power in the wisdom of the mob, so to speak. I think even, what was that game? You want to be a millionaire? You could, like, ask the audience, right?
Oh,
And
right. Yeah.
there is a power there. I mean, there is a way
Mhm.
to look at the average of decisions, and in large groups, typically it's right. It's very hard to be wrong on average when you look at a large enough group.
Mhm.
But change and innovation and power can come from individuals. And I have a very crystalline example, and hopefully you guys recall this. Are you guys familiar with Tank Man? Tank Man?
Yeah. Yeah. Totally.
Okay. So Tiananmen Square,
Yeah.
there was a revolution in progress where students were protesting in this giant gathering space, and it was crushed by the government and put down. So you had thousands, tens of thousands of people, and many hundreds, if not thousands, were killed in this repression of change. And then there came, and this was without visuals. Okay, this was in a place hidden, let's just say. And then there came a point where there was a column of tanks, and these are like legit tanks, 60-ton tanks. These are battle tanks. Okay, and they're driving, a column, and they're getting close to a series of hotels. The implication being people could be watching, they could be filming, they could be observing. And there was a guy, just a regular guy, not an educated man per se. And if he was, nobody knows. And that's part of the allure of Tank Man. There's a guy carrying groceries, just had bags of groceries in each hand, just wearing a white shirt, regular pants. And he's about to cross the street, and he sees these tanks coming. And he must know what's happening, obviously, by his actions. And he makes a choice. He chooses, as a singular human being, that I think someone's watching, and someone could take this visual, and I'm going to create essentially a fork. I'm going to put a choice that has no good solution for my enemies, my oppressors, in that if I get in front of this tank, and fork is a chess term, okay, when you make a move where your opponent has the ability to move one of their pieces out of harm, but not both in the same move. So you will get one thing or the other. They get to choose what you get, but you will get one piece. So imagine you, jump your knight, and on one side is the queen, on the other side's the rook. You probably want to move your queen, but you're still going to lose your rook. You're going to lose nothing the next move. So his assumption was correct, by the way. There were Western media, there were news people that had a camera on this guy, a movie camera. And eventually, obviously, we've seen this, they were able to smuggle out the tape. That's a story in of itself. But this guy put a fork move on. He saw an opportunity where you had the column of tanks that are unstoppable. So he could walk in front of this column, which he did, and they could run him over and turn him into a smear on the ground, which they didn't do, but they could have, obviously. But that could have started a whole new fire of revolution that would have toppled everything. The alternative was they stop. But that sets a really dangerous precedent where one man with power of self as a leader can stop a column of 60-ton tanks, and that's what happened.
Wow, yeah.
And so that's what I see. And then back, let me just part two. Dunning-Kruger, fascinating. Obviously, my version, not my version personally, but what I focus on is kind of a self Dunning-Kruger, and this goes into this consciousness competence matrix. So, and we've probably discussed this on the pod before. If we haven't, I think it's worthwhile. So we all start off and we're learning something new incompetently, but we're unconsciously incompetent. We don't even know how incompetent we are. Okay. And then we become conscious of our incompetence. So you start out unconsciously incompetent, then you become aware once you get trained by a competent person. Oh, I don't know what I'm talking about. And you can become consciously incompetent. Then you can move towards competency. Now you've gathered your skill. You're consciously competent now. If you put your mind to it, you can do this task in a competent manner. And then you get to the last component, which is unconscious competence. Now it's almost unfair as an expert. Your intuition is so strong. You don't even have to know why you're doing something or think hard about it consciously. You can just do things, okay, because you have 30 years of training or whatever. And I think that's very similar to Dunning-Kruger in that people weight their competence in the beginning in a form that is clearly demonstrably not there, right? The Walmart person may not self-evaluate as such, but if you're not a brain surgeon, you should not be cutting people's heads open or whatever, right?
Yeah.
But then if you actually go through, pre-med, and then you get your graduate rotations and you residency and your board certification, and now you start cutting people's heads off, well, you're probably not too confident even then, even though you're the expert of experts. Like, how hard it is to cut a person's brain open, take out this piece, not that piece, and put them back together and have them go about their life. So I think they're kind of hand in glove, and it's very powerful to understand your trajectory, whether it be Dunning-Kruger trajectory or competency consciousness matrix trajectory, where you are as a self-evaluation. I think it's a very powerful tool.
Yeah, I agree. That's brilliant. This is a nice fun tangent into this side carrot thing.
Yeah, great side carrot.
Yeah, so I think I want to try to pull it back into the topics here. But yeah, thank you guys. I love going through these things like that. So okay, so awesome. So we're gonna get back into the three-body solution thing, but before we actually do the solution, thought it'd be good to kind of do a quick recap of the previous three parts. So if you recall, part one, we talked about dimensions, flatland, and that this has come up many times in our podcasts and just in our conversations. This idea about flatland and the next dimension up and all of that stuff. So if by chance you didn't listen to that episode, seriously go back. There's a disclaimer at the beginning. The thought experiments really are worthwhile to carve out time to just sit, close your eyes, just really, don't do this while you're driving is what I'm saying. So that was like a really fun one. And I don't know how much detail we want to go into, but one of my favorite things, Bob, was how you kind of explained the 10 dimensions in terms of coordinates on a graph. Positive, negative, positive, in terms of length and height and width, I believe, and length being this dimension that you can kind of look at the center and see it coming towards you, and then the other side of it kind of going away from you. Really fascinating stuff. Really enjoyed that. Any things you guys want to touch on specifically from that episode, that concept?
I was playing with it a little bit yesterday, and I have not got it figured out mathematically just yet. But I do think there is something going on with having those 8 dimensions and the missing mass of the universe. I really do believe there's a connection there, and I don't have it figured out yet. I may never. I'm not a genius. I'm moderately intelligent at best, but I do believe there's something there, that the missing mass in the universe, the dark mass, the dark energy, it's all there, but we can't see it because it's not in the 3 positive dimension that we inhabit.
Yeah.
I concur. And
very, very cool. Yeah.
And just to add on top, I think great summary and nicely done, Tucker, taking it. I'm interested. I haven't sat down and divided up the quadrants and etc. It sounds like there's a proportional overlay there that does match up somehow to what standard model predicts is what we're missing, in that we don't have direct evidence. We have indirect evidence, circumstantial evidence, if you will, of the effects of dark energy and dark mass, etc. But here's what I'm getting at. The difference between what string theory and what the three-body problem piggybacks off of string theory, with the requirement of 10, sometimes 11, M theory 11 dimensions, is that every other version of how do we get to this, how do we explain this mathematical necessity of additional dimensions, one is higher dimensions, the other one is lower rolled up dimensions. And what I'm trying to get to is the graphic representation of 8 spatial dimensions, 4 on our side, quote unquote, of the universe, where you have the matter side, and the other side being the antimatter side, if you will. And then there's obviously 2 dimensions of time. So we have 5 and 5 on our universe and our mirror universe. So in our side, what I'm saying is you can mathematically break it out into these quadrants, but it all happens in one space, meaning all those quadrants are broken out graphically, but it all happens here, right here. Everything's here. There's not like a lower place all rolled up that is tiny, tiny, and a bigger place that's outside of our dimensional loop, if you will. It's all right here. It's all here. So it works with the effect of dark matter and dark energy right here. But it's offset in that we are bound, we meaning we are matter, not we are matter, not energy, but we are, our trap is we're trapped in the positive length, positive height, positive width coordinate, but it's overlaid. Like everything, imagine all four quadrants of the positive length are all overlaid on top of each other. That's what I'm getting at, is it's like a middle ground, if you will, between low dimensions rolled up and higher dimensions. Is the dimensions are a function of wave properties oscillating positive and negative, but it all happens here. It all happens right here. And so we're going to get into that further, but I think the recap side is just imagine there's additional dimensionality at hand, not tiny, tiny. So we have sophonts in the book, in the shows. We have these sophonts, which are tiny three-dimensional objects, but when they unfold to two dimensions, they are vast. And literally two dimensions. That's the theory in the author's concept, is if you take what the amount of size is of a three-dimensional proton and you unfold it to two dimensions, it can encircle the entire globe. It's a massive, massive distribution. You're essentially going from volume to surface area. So to imagine taking all the volume inside of a three-dimensional object, and more dimensions are rolled up inside, even more, but then to flatten it down. So really it's a 10-dimensional object, if you will, but you flatten it to two dimensions. The surface area is immense. It's this massive surface area. And so that's what I'm getting at, is imagine it's not tiny rolled up dimensions and it's not higher dimensions outside of us. I think Tucker brought this up once upon a time, where as you go up in higher dimensions, you should be able to see more of the universe, and then further back in the universe, and then the multiverse, etc. Right, Tucker? Is that fair summation? So having the ability to say, no, all of the extra dimensionality required by string theory is here, right here with us. But we can only see the parts that are positive length, positive height, positive width. But there's oscillation effects like magnetism that oscillate around that quadrant and allow for magnetism and gravity, like gravitational waves and magnetism, to pass through anything and all things. There's no matter other than like a conductor that pulls away the electromagnetic field. There's no mass. So when you go in an MRI machine, nothing stops the magnetic field from passing through your body. Whereas if I put a lead blanket on myself and went into an MRI machine, it would still go right through, but an X-ray would not. So the ability to have, and gravity, of course, goes right through the lead, right? The lead just adds more gravity on top of gravity. So the point is, gravitation and magnetism are exploits of this extra dimensionality, not lower, not higher. It's right here with us in the quadrants, but not broken out. All the quadrants collapsed on one another, but variations of the way waves oscillate. So I know there's a lot of stuff right there, but just trying to.
Yeah. Well, I was going to ask a question, maybe help kind of clarify, even just for myself, because I like how you said, well, like maybe they're all here. I think you said bound or stuck to this positive length, positive height, positive width quadrant. When you say we, like you mean human beings?
Massive things. So things that have mass. So matter. So matter is a directional wave, meaning it's a wave that passes through length, height, and width, but it's caught up, it's bound. It's actually two waves simultaneously. This goes back to E equals mc squared. So if you imagine E equals mc squared, c squared is an oscillation of positive height and negative height along length, and positive width and negative width along length. So going back to dimensionality, the looping, the dimension is something where you can cut a loop and it's still one piece, right? So if you have a string, and I cut the string in the middle, it becomes two pieces of string. So if I take a piece of string and I make a loop out of it and I cut it, I still have one piece of string.
Mm-hmm.
Okay, so the dimensionality is in the looping of the thing. What I'm saying is mass is a function of two oscillating loops along length. One is height and one is width, and they're 90 degrees opposed. So if you look at a diagram of electromagnetism, you're going to see there's a electrical oscillation, and orthogonal or 90 degrees opposed is a magnetic oscillation, and they're in phase. And if you take that as a piece of string that's vibrating both up and down and left and right along that length of string, that's like a photon. But then if you loop it around and connect it, now you get into magnetism. Now, I mean magnetism in that we can use the magnetic component of the oscillation of the string to affect. We're getting a little bit too deep here, but let's just kind of take this real quick. So imagine bonding. There's three kinds of bonds, chemical bonds in the universe. Covalent bonds. I'm blanking. I'm not so apologetic here. Ionic bonds, covalent bonds, and metallic bonds. We're talking about metallic bonds here. Metallic bonds are very special in that the metallic group of the periodic table essentially has a shared flow of electrons. So the electrons kind of pool amongst one another. So the giant atoms have many layers of electrons, and the electron negativity, the closeness of the electron to the nucleus is bound by increased strength. So the lower the level of the electron cloud is, the more it's bound to the nucleus. The higher up it goes in an electron shell configuration, the more it like sloshes around. So metallic bonds are, if you took, say, iron, and you make a cluster of iron atoms together, there's this effect where they bind to one another, but the nucleus, these giant nucleuses are kind of centrally located, and there's a shared pool of the upper boundary of electrons, and they begin to swirl, as it were, or not be owned by any one nucleus. So like the electrons are shared, and these shared electrons then are spinning. And if you can polarize or unify the spin of all these electrons in the metallic bond material, you get magnetism.
Mm-hmm.
So everything is essentially potentially a magnet because electrons spin, and magnetism is just the ability for an electron to pair its spin with all the other electrons, and they all spin in the same direction at the same time. But they're also orbiting. So you get this dimensional effect of something orbiting, and then it's spinning while it's orbiting. So it's like, imagine something orbiting clockwise, but it's also spinning clockwise at the same time. Now, I know they call spin up and down, but imagine instead of spin up, spin down, it's spin clockwise, but it's also orbiting clockwise. So you get this nesting effect of dimensionality that allows for bypass of the positive length, positive height, positive width dimension.
Wow.
So what I'm saying is mass is a collection of bound waves. Two opposing waves, meaning a height wave and a width wave along length. So the wave is length. And once you can loop these things all the way around and connect them one to another. So let's go back to real quick X-rays. So why don't X-rays, because they're waves too, these are photons, why don't they go through the lead sheet, but magnetism does? Okay, It's a very interesting question. It's what got
Yeah.
me here. So you have like a bullet is being shot, meaning the length is coming right at you. So imagine you are the target and length is coming right at you, but it's oscillating. So that photon is oscillating as it's coming at you. And it's oscillating both on the height plane and on the width plane. So long length coming towards you, it's oscillating. When it hits that lead, the giant atom nucleus of lead blocks it. And they're tiered. So it's like Swiss cheese, of course, because the atom is not a solid object. It has holes in it, if you will. But just like Swiss cheese, if you stack layer on layer on layer of Swiss cheese, all the holes kind of average out.
Yeah.
There's no way to look all the way through the cheese, right? Even though there's holes in it. So the blanket is like Swiss cheese. You've got all these lead atoms that have holes, but when you put lead together in a layer, it will block the photon, which is pure energy, it's massless, from penetrating that. So the X-ray will not penetrate the lead to go through your arm to hit the photo plate underneath. So you will see nothing underneath. It protects you from the wave going through you. Magnetism is also a wave, but it's in orbit. So you have this metallic bond of a, say, piece of iron. So you have all the nucleuses bound to one another, metallic bond, and then the pooling of the electrons that are polarized. So when you put a magnet next to another magnet, you kind of unify the polarity of the spins and the orbits, and it creates this unified effect we call magnetism, but it's in a loop. So you bring a magnet to the lead barrier, the effect of the magnetism goes through the lead because it's in this looping configuration. And that looping configuration is not like a bullet shooting straight at you. It's circling, but it's not just circling. The electrons in the orbit are spinning. And this is how you get to the other quadrants. So we talked about the positive length, positive height, positive width. So that's where the lead is at. But to get around the lead, you have to oscillate into, say, negative height, negative width, positive length. You see what I'm getting at?
Yeah. Wow.
And so by having all the dimensions here with us, right here, it's in the room with us now. What's that mean, right? Is the dimension in the room with you now? It's like, yes, it is. It's right here. It's all here. All of it's right here now. And you can access it through the looping. So the looping on looping on looping is what creates, because let's go back to E equals mc squared. What happens when you snip? So if I'm saying matter, not me, Einstein says matter is energy and energy is matter, right? E equals m. So energy equals matter. Well, what happens is the matter is looped. So it's a looped wave and it propagates at the speed of light. But if you snip that, you don't destroy it. You cannot destroy energy. You cannot destroy matter. It just converts one to another back and forth. So when you cut the loop, it goes flat. And that's energy. When you bend the loop such that it connects with its own tail and it turns into, like, it can go clockwise or counterclockwise, now it becomes matter. And back and forth it goes forever. It never dissipates. It's just, it spreads out, but it doesn't disappear. And you can't create it either. So that's what I'm getting at. The dimensionality is here with us now, but us as beings comprised of matter, we can only detect, meaning actually detect. So the dark part, dark energy and dark matter, we can detect the effects of these things. So we detect the expansion or accelerated expansion of the universe. That's our dark energy. And the gravitational field of dark matter we can detect, but there's nothing there. Can't point to it. We see the halo effect around these galaxies. So we can infer that the galaxies, if they were really a function of all the visible mass in the galaxy, the center would spin at a different rate than the outside. So look at our Milky Way galaxy. If you could look from the top of the plane of the Milky Way galaxy's plane of rotation, what we see is the spiral arms rotate at roughly the same speed as the center. That don't make no sense. So what happens is we infer there's a halo effect of dark matter around our galaxy, which, if you can imagine, it increases the gravitational field such that the place that is rotating is all roughly rotating the same speed, because it's not really the edge of anything. It's still the center. That's kind of confusing. But the point is, this halo effect, we know there's a gravitational halo around these galaxies that influence the spin rate of the spirals, such that we can measure that and detect that there's an effect due to gravity of some matter somewhere, but you can't visualize it. It doesn't exist in any way that we can see it.
Well, and
Yeah.
I mean, just this whole discussion we've had about these topics has led me to the point where I kind of, when I say I believe something, it means it's not a belief, it's something I'm entertaining currently as thoughts, but it makes me believe that information actually does have weight, just not where we're at. So where the plane we exist in, only mass has mass. But I think we can look at it as, mass is just a rock. It's a simple thing. Like, it's a pretty insignificant part of the universe we inhabit. Where the real meat is the information. It's the ability to look at something and describe it.
Mm.
And that has weight somewhere in one of these other dimensions that we don't see. That information has 80% and 7% of the weight of the universe. It's the information that has the weight, just not where we're at. And we can't
Wow.
see that. We only see the mass in our 3 dimensions, and that's what has weight to us. But it's only 15% of the universe.
Yeah, I'm remembering now when we went through this first part that my brain was melted much more than from the beer I drank that's named Brain Melter. Just from listening to, these things. What a great jumping off point for this whole thing, It's just like,
I didn't
here.
expect to go there, but I think it flows, like, because if we really want to know, like, this is what I'm talking about. This is the actual extrapolation of very commonly accepted science facts and understandings reinterpreted. So I'm not saying I have any direct experimental facts or figures that are exclusive
Evidence.
to me and me alone. Yeah, I don't. I'm just saying, if we reinterpret the meanings of certain things, such as describing dimensions, because there's no rule book that we've found from on high that says length is a dimension. It's just something we've defined. But what if it's a direction and not a dimension? What if the dimension is this, this function of multiple directions oscillating in unison in a certain way? And then back to kind of touching on what Tucker's saying, but the concept of, say, antimatter. So people in science fiction, I mean, I don't think we've made a bunch of antimatter, so it's very hard to say. But in science fiction, one of the ways to propel something around is to put matter and antimatter together. And what happens is they annihilate each other and create energy. And so the concept of having a spin to the direction, like the spin of time, if you will, and one being clockwise and the other one being counterclockwise, as they meet, they unwind each other. So they cut each other's loops and flatten each other out instantaneously. So that's how I see, because one of the great questions is, why is our universe so much matter and not very much antimatter? And nobody has an answer for that, as far as I know. It's one of the great mysteries. Like, why do we have a matter universe? Why don't we have a mixture of the two? Because we can produce antimatter. We know it exists. But why is it not evidence? Now, maybe it's already annihilated itself because it came into contact with matter. But then why is it in the proportion that it is? Why are we so imbalanced? Anyway, the point is there's lots of mystery out there. And maybe building bigger super colliders is the way to uncover the mystery. But maybe just admitting that our framing, our perspective, our point of view of the current facts at hand are incorrect. So that's kind of where I start.
Yeah.
It's just the assumption that we do not have it figured out. Experts may be ignorant. We have plenty of facts that we can all look at simultaneously, but maybe it's the explanation of the facts that is a simple solution. And quite frankly, my solution to the Fermi paradox is that these answers are so clearly, obviously self-evident when looked at the right way, that it's a very, very, very easy solution that people, meaning intelligent life in the universe, that they all discover this thing very quickly and they go into these places that we cannot see.
Wow. Fascinating.
Yeah, no, I like that too, because I mean, just going back into the information as weight, that's one idea. But I mean, we're talking almost spin states at this point too, where it's, what if those other 7 dimensions are there and they actually do have matter, but it's spin state is such that, our tools, our eyes can't perceive it as matter. So yeah, okay.
That's exactly what I'm saying. That's
85% of the universe is there and it's teeming with life. We just can't see it.
That's exactly what I'm saying. That is it. Precisely.
Yes.
So we get the effect, but we can't see the cause.
And again, I'm going to go back to the question I asked earlier, like when both you just said we just there, we both use the word we, like now you are kind of talking about like human beings, right?
Sure.
And again, like perception, well, let's just take the visual sense of perception, like we know that we're limited to the visible spectrum of light radiation, right? And there's all these things we know that are there, but like we just don't perceive with our eyes. So it does seem reasonable for, I think, to assume or believe even that, yeah, just because we can't see it doesn't mean, it doesn't exist. And then I wonder, like, to speculate even further, Tucker, you mentioned this like way back, maybe it's come up in an episode, but what's the kind of shrimp that has, we like human beings' eyes have what?
I think it's the mantis shrimp.
Yeah. So human beings have like 2 types of receptors in our eyeballs, right? 2 rods and cones or whatever. And mantis shrimp have like 17 or some crazy number,
14
right?
or 17. Yeah.
Yeah. So what do they need that for? What if they're able to perceive some of this stuff? Do you think that's like totally ridiculous, or do you think that's?
I think that's a great analogy. I think that's
Bob,
exactly
I know you can speak to this.
Yeah.
You have cats.
Yeah.
Those motherfuckers see shit that we aren't seeing.
Exactly.
100%. Those motherfuckers will stare into the corner of a room looking at something that I can't fucking see.
Well, what's so interesting is their lack of one type. I think it's cones, I believe, see color, gives them a prevalence of the other type. I think it's rods. I could be corrected. Meaning they are so singularly focused, pun intended, on being able to differentiate between contrast of light and darkness. They give up the ability to see color. Whereas mantis shrimp, they have
all the colors.
Yeah, exactly. So back to John's point, which is I think is a wonderful analogy, ultraviolet and infrared.
Yeah.
And we could keep on going on the spectrum, X-rays, radio waves, gamma rays, all these different ray types are all just frequencies of light. That's all we're talking about is frequencies of light that we have a spectrum of. And just like you're saying, John, I'm going to borrow this and I'll give you attribution, of course. This is what I'm talking about. We get to see in a spectrum of matter that's positive length, positive height, positive width. So it's not a function of frequency. It's a function of oscillation state of the waves, but it's in a spectrum, like you're saying. So the coordinate, the quadrant system, is like a spectrum. That's exactly the analogy I'm trying to get to. I love it, in that we are stuck on the visible quadrant of matter of positive length, positive height, positive width. That's our visible quadrant of matter. But it extends into ultraviolet and infrared and whatever, all the other parts of the spectrum. And that, I'm not going to say all the configurations, but you know what I'm getting at.
Yeah.
The other quadrants of dimensionality is what I call them, are just exactly analogous to the spectrum of light that's outside of our vision. That's exactly it.
Yeah. I fucking love this stuff, you guys. Okay, so that was only part one of this kind of, the three parts we have done up to now. So part two was specifically talking about Newtonian gravity, and this concept of the barycenter came up. And I don't think we said this in the episode, but I'd love to just share it now. This idea about the barycenter, this kind of came up, or I think organically, like in a pregame kind of chat we had, the three of us, that I think, we were just kind of talking about riffing back and forth on ideas, and how very similar to Tucker and I's experience in the band, how it, and I use the word riff intentionally here, how,
Nice pun.
Yeah. By the way, pun intended. Be brave when think about that. When people say like pun not intended. Why intend the pun? It's like, well, don't be scared.
So
like yeah. Intend the pun. It's so fun. Thank you. But I was going to say that we kind of came up with this idea that metaphorically, maybe this barycenter is a thing that we can refer to as like a real thing that happens when people are sharing ideas, and that moment when, just like writing music, a riff occurs. It might come from somebody's fingers, the idea might come out of somebody's mouth, but the idea didn't maybe originate there. It originated from this invisible thing we can't see. Maybe it's dimensionality, right? Maybe it's not at all. Maybe it's pure metaphor. But I love this idea that pure creativity, might exist, a form of pure creativity. I wouldn't say like the only. I don't want to be absolute here, but I love this idea that there's this idea that a form of creation, a form of creativity, of something coming into being out of nothing. It wouldn't have existed before, might originate outside of our brains, like a shared consciousness thing, like as the ideas are flowing, and much like the barycenter, this place that it comes from happens to just kind of float in this ether. and in the moment of inspiration, like a person just is compelled to draw from it, and then the riff comes out of the fingers, or the idea comes out of the mouth, or whatever. But oh god, I just love that idea. And again, we didn't really go into that in the part 2 episode that we did, but I thought it was appropriate to share, because I know I think all three of us were like, yeah, that actually sounds like a fun idea.
Yeah, it's not me, it's not you, it's the space between us that is really producing this thing. I 100% agree. It's not the speaker, it's not the listener, it's the conversation, it's the emergent. It's an emergent phenomenon. That's the key.
Mm-hmm. Yeah,
well, and I think it's I think it's important, like when we're talking about gravitational waves. Okay, that is a wave of gravity rippling across the fabric of space-time, right?
Yes.
But when we look at space, it's just an empty vacuum, and vacuums don't ripple across. You drop a pebble into a pond and it ripples. You drop it onto a piece of glass, it just stops, right?
Mm.
So there has to be something more than an empty vacuum for those ripples to carry on.
Exactly.
It's a physical thing, just not here.
Yes, it's got to oscillate into some other area. It's got to expand and contract into some other area in order to be a wave. That's exactly it.
And again, it's
not empty. It's just not where we can see.
Yeah, when you say it's not here where we can see, right? I mean, does that mean but it still might be here, we just imperceptible to us, right?
Sure.
Yes, but what you can't see is where it's oscillating into and out of. So imagine like a cube of Jello, and a cube of Jello still like meaning still, it's not perturbed, it can fit inside the quadrant of positive length, positive height, positive width. But if you flick it and it starts to jiggle, if you have a perfect cube shape and a perfect box around that cube, that jiggling is going to jiggle outside and inside the line built around the box, the surface area. And what I'm saying is the jello is still the jello, but the pattern of the jello oscillates into and out of these other physical spatial dimensions.
Wow, that's a really good. I like that one a lot. Yeah.
Yeah, it's not the thing, it's the pattern of the thing. So the thing is the jello, the thing is the water, like Tucker's saying, or glass, right? We're looking at the substrate, but we're not envisioning the substrate has to oscillate in and out of somewhere. It's gotta, I mean, that's the whole point. It's gotta be oscillating into and out of somewhere in some direction. This goes back to dimensionalities, another up and down. There's always got to be another up and down to have another layer of dimensionality. From a point to a string, from the point's point of view, the string has a new up and down. To a sheet of paper to the string, the sheet of paper has another up and down compared to the string's up and down. It has a second up and down. It's not just length, it's now width as well. Cube has another up and down to the paper. It's got an up and down a height. And I'm saying it keeps on going, not me personally. It's the flatland idea. Is you can extrapolate this beyond your reach, beyond your physical reach. You have to be able to extrapolate the truth of the idea. And that's why I contend we don't need, I'm sure we can definitely get better machines and better telescopes and super colliders and all the rest, but I'm saying, what if it's simpler than all that? What if we have the evidence at hand? It's just in our face. And it takes a re-envisioning, a reimagining of the evidence at hand to unlock the true or more informed understanding of the way things are.
Yeah.
So, and back to, I do want to kind of lily pad hop this thing. So into the Newtonian side of things, it's not so much, we kind of jumped ahead. It's not so much the rippling of the gravitational waves, that's Einstein. Newton is the gravitational constant. The idea that there is I'm not going to go through the whole thing, we have an entire podcast on it, but the proposition that maybe what the gravitational constant in our Newtonian formulation, classical formulation of mass 1 times mass 2 over distance squared, it's not really a constant. It is an actual physical thing. It is describing an outer shell of the universe. So an outer shell of the universe, if we are in a spherical representation, if we're at the very center of that sphere, but there's only one of us, you would just be locked in position. You wouldn't feel anything because you're pulled in all directions at once. But if you were to do an experiment where you and another massive body are in the center, you'd have mass 1 times mass 2 over distance squared times the gravitational constant times the effect of this shell around you pulling you out in all directions at once, countering your attraction to one another at the center point. And it goes back to the barycenter is now inside the object as opposed to shared space between you and me. I'm not inside you, you're not inside me. We have a barycenter in the space between us.
Yeah.
But maybe that's not always the case. Maybe the barycenter is actually inside one object and we're inside that thing too. So then we get to the third stage, which is general relativity. Einstein's idea that gravity is not a force, it's a curvature of space-time. That's how we get gravitational waves, which he predicted. And we have documented, LIGO. We have an interferometer that is able to detect the contraction and expansion of these pulses of gravitational waves, which are rippling through the fabric of space-time itself. So my proposition then is the gravitational well that we know and can see, well, black holes we can't see, but the gravitational well that we're all familiar and accepting with in a common sense sits on top of a gravitational hill which is the gravitational constant itself. So if you can re-envision the sphere, because it's not really a sphere, and we'll get into that today, but let's just say there's a spherical shell. We're inside the hollow Earth. Well, that can be envisioned as a hill. So if you move to one side or the other, up, down, left, right, north, south, whatever you want to call it, north, south, east, west, up, down, if you try to go in any of these directions, you're going to start sliding down the hill and get pulled more and more quickly towards that side because of mass 1 times mass 2 over distance squared. As you go closer to one edge than the other, the gravitational curvature, the effect of gravity, the feeling of gravity is going to increase due to your closer distance to it by the square. So if you get closer to the edge, so imagine the universe's shell is so far out. We are so tiny. It is so massive. It's so far out that according to our measurements here, it's essentially indistinguishable from any location. Like we haven't gotten far enough away from any position we are at to make an experiment to measure the gravitational constant somewhere else. And when we do a two-body problem, we can calculate it because as the two bodies rotate around each other periodically, the same path over and over again, they are averaging out that distance discrepancy. Kind of jumping ahead now to the solution here. So once you add a third body, you mess with that average. So two bodies average one another out in their distance discrepancy to the edge. Three bodies do not. Once you add a third body, there is a minute discrepancy in the distance squared between the center of its mass and the so-called center of mass of the outside shell. So that's the solution. The solution is it's essentially chaos theory, where very tiny micro distribution of changes create outside effects over time. So tiny little imperceptible changes to the gravitational constant between the three bodies, where you have two that are, let's just say, synced up and in a periodic rotation, orbit amongst each other with a shared barycenter. Once you add that third body in, it swings wildly through and disrupts everything. And what eventually happens in most of my understanding, most of the observed occurrences is, or modeled occurrences, if you will, that third body creates a disruption that eventually ejects one of the three bodies. And then it goes back to a two-body state with a periodic orbit, with a shared barycenter. So once you introduce that third object, you're introducing chaos into the system. And this is why they cannot ever predict in the storyline the chaotic era and the stable era. Right? That's the whole thing of the story, is that they're stuck.
Yeah.
They're so small, they're insignificant compared to the three stars. But the three stars are unpredictable because they cannot predict a periodic motion, no matter how hard they try. And by the way, someone Google check me, please. There's once upon a time a competition to determine, I think it's Poincaré, I believe. Poincaré, I can't know if I'm pronouncing that correctly. There was this guy who comes up to solve this problem by, I think it was a king of some European country or whatever. And he's like, I want to figure out, why can't we figure this thing out? I want an answer. And the answer was, you can't get an answer. The answer was, it's unanswerable. It's literally unpredictable. That is the three-body problem. It's literally impossible, is the understanding of today. Is this literally impossible? There is no solution, is the solution. But they don't say why. It's just impossible. And so what I'm saying is, it's absolutely possible. But you have to understand the gravitational constant is not a constant like the speed of light is a constant. The gravitational constant, excuse me, is a physical manifestation of a shell around the visible portion of the universe, but it's way far away. And it's so much more massive than anything we can even imagine inside the universe. And it's pulling essentially in all directions at once. And we're going to get into that here in just a second. Pulling in all directions at once. But the only thing that you can tell is instead of two things averaging out that difference, that minor difference between the gravitational constant, is when you add a third thing. And now there's a disequilibrium between the average distance between the edge and where we are.
Yeah. I'm with you.
Yeah.
So let's do the first thought experiment. And this goes back to Flatland. We're going to do a thought experiment, step down a level. Because one of the hard things, why I think this is not already figured out, is how difficult it is to have intuition or a mind's eye point of view of additional dimensions.
Yeah.
That's why I did the graph. It's got to be mathematical. It's got to be an abstraction. Okay. To really understand the actual quadrant system, you have to break it apart and abstract it mathematically. But the reality is it's all overlaid one on top of another, on top of another, on top of another. So in order for us to have intuition, I want us to do a thought experiment that has to do with stepping down a level. So imagine we're two-dimensional. We live in a two-dimensional universe, and a massive object is a circle, and an energetic object is a line, let's just say. So circles on a piece of paper. So let's draw some circles on a piece of paper. But then imagine there's a sphere. And obviously we've gone through this a million times. As a sphere passes through the piece of paper, we would acknowledge the sphere as a circle itself. So we can't detect the up and down of height when we're stuck between length and width of the piece of paper. But as it passes through, so let's say a circle is passing through, it started as a little tiny dot, then it would grow as a bigger circle until it got to the equator, and then it would shrink in size until it came back down to a dot again. So that's what we would experience a sphere passing through our universe would look like to us. But what I'm saying is dark matter and the gravitational effect that we infer dark matter exists from, so we have the effect of the gravitational field of invisible stuff. And we're just making up this term dark matter, saying that we have proof that there's gravity there, indisputable proof that there's gravity there, but there's no stuff there. So imagine we're in the piece of paper, and as you pass, let's say the size of the circle is a function of its mass. And the bigger the circle, the greater the gravitational field. And so we can do math then on a piece of paper, one circle to the next, how attractive one should be to the other. Then imagine we pass a sphere through, and we can only see then the circular part of the sphere. But let's just say in the thought experiment, the volume of the sphere impacts gravitationally. So the volume of the sphere outside of what we can see, invisible, it's dark, is still bending the fabric of space-time. Even though the only component of the sphere that we can acknowledge is the sphere as which the circle, as it passes through our plane of two-dimensionality.
And real quick, like you said, like you see it a circle. Maybe I missed something along the way, but wouldn't it be a line? You know, that would be. You wouldn't actually see the circle itself; it'd just be the line, right? Or
You're correct. You're correct, but we're not trying to do the thought experiment as a point of view. We're trying to talk about the force of gravity or the curvature of the space-time itself. You're not wrong. You're 100% correct, but we're not saying the point of view of one circle to the other circle, which you're absolutely right. It would be a line.
Okay.
What I'm saying is imagine a piece of paper with circles on it, but we're still objectively a third person point of view of the piece of paper.
Yeah. Okay. Gotcha.
So we can see that everything's a circle. You're 100% correct to each other. They would seem as a line, and the sphere itself passing through the piece of paper would look like a tiny little dot. Then it would be a longer line till it hits its equator, and then it would shrink. But we're trying to say, okay, this paper universe, the circles have an effect. So we talked about mass or E equals mc squared. Something massive is energy, and something energetic can be massive. Depends on whether it's in a straight line or it's looped. So imagine instead of two simultaneous waves going along length, so E equals mc squared, instead of squaring the speed of light, we're only talking about one. We're just talking about width, there's no height. But as you pass the sphere through it, which has height, what we do detect in the paper is the effect of the curvature of space-time, or the force of gravity, whichever term you want to use. But we cannot detect the spherical portion above or below the piece of paper. It's impossible when you are in the piece of paper to detect above and below the piece of paper. But we can detect its effect. So that's my contention, is dark matter and the gravity that we observe from dark matter is analogous to being in the universe of a piece of paper where a sphere can pass through, but the vast majority of the sphere's influence is not along the two dimensions, it's above and below the two dimensions. And we are the circles on the piece of paper.
Wow.
And sorry, go ahead.
No, I was just say again, my brain is just goo now. Anyway, yeah, no, keep going.
Now, try to do that where you have 3 dimensions and 4 dimensions or whatever, and that's where it breaks down. It's impossible for us to have intuition or visualization of that level. The trick is to do the Flatlander thing, where you step down a level and you can still see it. We can visualize this thing happening. We can extrapolate from there to our reality and just acknowledge that that could really be happening. But we can't intuit. We can't feel it. We can't see it. We can't understand it at the level and above where we're at. It's just not possible. We're constrained by being in the thing itself.
I will say, having this discussion just now, I think I got closer to being able to see it. Have you guys ever seen the robotic hypercube?
Tesseract?
This is a they literally built it. You can look it up, but they built a hypercube out of pneumatics, right? So what they can do is actually make this hypercube rotate where the outside becomes the inside and vice versa.
Oh, yes, they use colors, I believe. So they use colors as an extra dimension. That's right. Yep.
But if you think about it,
I Googled it, and it was like all kinds of sponsored things, like on Amazon, and buy it here. You know?
Yeah.
Anyway, yeah.
So, okay, you have that one. Well, empty space is just made out of fourth dimensional hypercubes. And the actual distortion is how those hypercubes have to orient themselves around a physical object. So the way that they have to turn themselves inside or outside of themselves around an object is actually what we're seeing as the distortion in space-time and allows those gravitational waves to travel, is because it is actually a physical object. It's just not one we can see.
I think that's essentially, yeah. I think I agree with that. Yes. It's literally there. It's literally on top of, everything's on top of it, other things. But to us, another up and down is unreachable. Just like on the piece of paper, it can't reach up into the spherical volume sense, even though it's right there. It's right there. It's just above and right below you. Can't you see it? You know, like if you're in a sphere talking to the circle, like, can't you see it? Just look up, right? And he's like, up where?
What is up?
What is up? I know north, south, east, west. What is this up? And it's like, no, imagine take your entire universe and stack it on top of itself. Well, what does that mean? Like, to the paper, what does that mean? It means nothing. It means absolute nothingness. It doesn't make any sense. It's nonsense. And maybe it is nonsense because you can't reach out and get there. But I'm saying there's an effect that we can measure, that we can infer, that there is another up and down. There is another more spacious space dimension that we can reach into, or not. I mean, I think we could. It's an off topic. I don't want to go there, but like black holes, right? So maybe there's ways to punch into these things and then they kind of disappear on us. The light doesn't come back. We can't shine a light on a black hole and see its reflection. So maybe that's pretty clear evidence that there's a space in there that we can't see. Why? Because it's like the piece of paper trying to look up. So let me just dovetail on that, and I think this will kind of crystallize it. Imagine the piece of paper, but you're not drawn on top of the piece of paper. You're like inside the piece of paper. I know it's like two-dimensional, but you're inside the two dimensions, and you're probably already figuring this out. But imagine you could slide around. So imagine like a table. So you got a table, but I'm cheating a little bit with depth here, but inside the table, let's just say it's hollow. Glass top table, but it's hollow. There's like a chamber in there, let's just say. And you put a ball bearing in there, an iron ball bearing inside this table, so it can move north, south, east, west, but it's incapable of moving up and down. And then you say you have a magnet. And you could put a magnet above or below the glass table and exert a force on the ball bearing inside the table. But it's not going to move up or down. So if you move that magnet left to right, north, south, east, west, over the table or under the table, the ball bearing will move. But it has to move north, south, east, west. It can't move up and down. So you can influence that ball bearing from up and down, but you can only make it move north, south, east, west. You get me?
Mm-hmm.
Okay. So that's another inference that I'm trying to make here, is that we feel the gravitational field from dark matter that is up and down relative to us, but we can only move north, south, east, west inside the glass table.
Yeah.
So we're bound inside north, south, east, west of the table itself, but the magnet is up and down, up or down, doesn't matter. It exists in a place that we cannot go to, but its influence as a field enters and exits through our table.
And we can observe its effects.
Correct.
Right. Yeah.
But we're bound to not go to the place that it's really pulling us to. You can't go up or down. You're inside the glass table as a ball bearing, but you will be pulled north, south, east, west, all over the place if you move the magnet. So now I'm almost to the solution. Let me do one little more piece here, which is we've been talking about a piece of paper.
Mm-hmm.
And so the curvature of that piece of paper, we've kind of assumed is flat. And we can say that space, as measured by scientists today, is considered flat, meaning the angles of a triangle add up to 180 degrees. I'm not going to go deep into this, it's too much math, but what we say is what we measure looks like flat space, but it's on a tiny scale. So on our planet, early hominids must have presumed they were on a flat world because their perspective was so small relative to the surface of a giant sphere that they could not detect it was a sphere.
Yeah.
Call back to your friends, on the internet, not your friends, John, but
Yeah.
people on the
Right.
internet who
Just look at it. I use my eyeballs. Look, the horizon looks flat. It must be
Correct.
flat.
Exactly. So today, our scientists, I propose, are the same kind of ignorant, where what they measure, what they can see in our point of view, as minuscule as it is, where we stand in this ginormous universe that we can see with the real universe far exceeding that, it looks flat. But there's other possibilities. So positive curvature would be a sphere. A positive curvature would curve upon itself and create a spherical object. Negative curvature becomes flippy floppy, like a piece of lettuce or a poncho, and they call it a saddle shape.
Mm-hmm.
So hyperbolic space, negative curvature space, folds over on itself. Like let's just go through a little thought experiment. Let's just say you had an orange and you cut it in half. So you have hemispheres of an orange. If you were to try to take a flat piece of paper and put it over that orange hemisphere, what would the piece of paper look like?
A dome.
But if you were to take a real piece of paper, an actual piece of paper, would it just fit like an actual dome?
It would have to crinkle. It would have to crinkle to form around the object.
And if you were to flatten that hemisphere flat, like on the table it sits, it wouldn't create a circle, guys.
Right.
If you
be wedges missing.
There would be wedges missing, exactly. So there's different allocations of surface area, relative and volume, but surface area let's focus on relative to the shape of the space itself. So there's less surface area on a positive curvature, because if you flatten it, it won't create a circle, it'll have wedges cut out. There's more surface area on a flat piece of paper, and there's the most surface area on a hyperbolic shape, a negative curvature shape, a poncho, if you will, or a piece of lettuce. It folds all over itself. Go back to Einstein. Einstein's saying there's not a force of gravity. It's a curvature of space-time itself. And one of our problems, I propose, is that we are under the belief that space is flat. And so we're missing the bigger picture of the true shape of space. And this is where the three-body solution comes in. Let's go back to flatland concept. We're going to step down a layer. So paper, 2 dimensions is the thing. It's literally where we are at is 2 dimensions, let's just say. And instead of being spheres of solid things, we can be circles. And a circle is a solid thing. So if you were to take a piece of paper and draw 2 circles on it and put arrows on the circles with length of the arrows to show the velocity and direction of the motion of these circles on the piece of paper, you could have some kind of approximation of what our 3-dimensional physics is like. We could call that, mass 1, mass 2, have the distance, have a starting velocity, directions, and we could calculate their orbit. Okay. Now take that piece of paper, roll it into a tube, and take that tube and connect the ends. Now you have a donut.
Yeah. Donut. Oh, anyway.
Donut. Yeah, Homer. But now imagine this: you're in the paper. You're in the paper.
Still in the paper, not in the empty space, but in the paper. Correct.
Correct. You are correct. You are in the paper. But relative to the overall size of the paper seems flat to you.
Mm-hmm.
Now so let's go back to this inside outside. So the paper now in a torus shape has multiple curvatures. So the inside diameter, that inside circle, if you will, of the donut hole, has a saddle shape. It's got negative curvature. The outside of the donut that reaches out into the infinite space of what's beyond the donut totally, has positive curvature. And then right at the top point, in the middle of the donut, if you will, middle of the surface of the donut, if you will, it's essentially like a flat space. So you can envision, if you were bound in 2 dimensions, but you're inside the paper and you're transiting, you're moving through the paper, there would be no edge. You would just go around and around and around. You could be going clockwise, counterclockwise, or inside the donut, outside the donut, meaning inside to the donut hole or outside to the outside of the donut. You could move, if you looked, quote unquote, from the piece of paper, it would look like infinity in all directions. If the donut expanded, meaning if the paper is expanding out, it would look like all other circles on the surface of that piece of paper all moving away from you in all directions. And the more it grew, the faster that expansion would be in all directions. Now imagine you combine that with not just circles, but spheres that pass through the donut. And plot on that piece of paper, not 2 circles, but 3. And have the inside of the donut, meaning the cake area of the donut, and outside of the donut, the everywhere else, be the new up and down. Now you see the solution to the 3-body problem is calculating where you are on the surface of this donut relative to the curvature of the inside portion, the middle portion, or the outside portion, and relative to the inside cake, and call it the outside cake. There it is.
Wow. Ding, ding, ding.
That's the end. That was 5 hours or whatever just to get to that one thing. Yeah.
No, I love it. Because I do remember in one of the previous episodes, the donut thing kind of came up, and it was like, I applaud you for the willpower to hold on to that, because I know you even said, I think, like, oh, we're getting too close to it. Not yet.
Big preview, I think it says. Big preview.
Yeah. Right.
So if there's a way then to extrapolate from that thought experiment and make it into 3 dimensions and higher dimensions above that, because it's not going to work with paper because we don't exist in paper.
Right.
So we have our dimensionality that we have, but I believe the principle holds. And I can't visualize it. I can't really go there. I don't think any human can. I don't think it's possible being bound within the thing you're trying to think outside of.
Right.
So stepping down a level, being a circle and not a sphere, but understanding a sphere is as a hypersphere to us would be, we would have spheres, and then this would be hyperspheres. So spheres inside of spheres, just like a hypercube is a cube inside of a cube. Imagining a place we can't go to because we feel the effect of it. And then imagining a geometry we can associate it with. There's got to be another geometry, is my point. That's not a torus or a donut. But I can't really imagine it. But if we are, as a piece of paper, in a piece of paper zone of flat land, curved around and connected as a tube, but the end's connected, so it's infinite tubed, and it can expand, and we're inside the paper itself, and everything looks like it's expanding away from us faster and faster in all directions, and everything looks infinite, and it looks flat because we're so tiny relative to the curvature of what's actually happening. We're insignificant. We're like an ant crawling on a basketball or something. It looks flat to the ant. But the effects that we can identify, these dark matter and dark energy effects that we can identify, and little quirks in the matrix, like the 3-body problem. This is why I'm so fascinated, because the 3-body problem is, to me, one of these points of falsifiability. So I'm positing these propositions. They might be true, they might be false, but I think they're testable. There's a reality to this thing. Where if I just stick to the math of the graph and like the quadrants, can't really do much with that.
Mm-hmm.
A 3-body problem, dark energy, dark matter, double slit experiment. We're not going to get into that today, but there are certain little flaws in the matrix that we can hone in on and use them without technology, meaning without having to build a super collider or whatever, and use them to uncover the truth underneath the truth, like what's really down there.
Yeah.
So hit me, guys. What do you think? What's your take? Yay, nay, don't know. You got questions? You got?
Yeah, I mean, like, I think there's definitely some things that I just, they go kind of quickly over my head, where I gotta like sit and really ponder it for a while. I think conceptually, like high level conceptually, I think I mean, I definitely I can see like that donut torus shape in my head, and all those things kind of like track, visually in my head. Do you think, like, in our lifetime, do you think that like there'll be evidence or anything like advancement, and understanding that some of these things will come and kind of be, more widely accepted or whatever in like the sort of scientific community? I'm trying to think of the best way to say that, but as opposed to just really kind of is still like total supposition, correct? Or is some of this?
Let's go good news, bad news. Good news first. Just saw that article about somebody talking about a gravistar.
Oh, right.
Talking about a star that's not a singularity collapse. It collapses into a shell configuration, and that's essentially what I'm talking about. Also, that other article. I mean, I never read the paper itself, but somebody talking about having like a negative time universe, something that goes times the opposite direction, kind of a thing. That's also part of what, because I do look at time as a dimension, but there's two dimensions to get to 10. In this configuration, there's 8 spatial, so 4 quadrants along positive length and 4 quadrants along negative length, and then the rotation of the spin of each direction is like the spin of time. It's like the rotation of the clock, and they are opposed to one another, mirror images, if you will. And so you get to 10 that way. So I do think there is creative ideas out there like this. And I don't know. I mean, the bad news is I've been working on this for maybe 2 years, two and a half years, something like that. I've been thinking about this. I haven't seen anything at all even close to these kinds of ideas, except for, maybe science fiction or something. I don't even know. I mean, this is kind of original stuff, I guess I could say, which does not bode well if I'm, fairly, if not absolutely insignificant. My reach of message is, very limited, obviously. So I don't know.
For now. How about for now? Yeah, who knows?
Now. But for now is what I'm basing this off of. So if for now persists into forever, then it would take somebody else who is, because here's my concern. Going back to Feynman, science is the belief in the ignorance of experts. So once you are in the expert lane, you go through your undergrad, your graduate school, your postdoc, maybe you get a faculty position, you become tenured. Like, everybody's got books to sell. Everybody's got a lineage of this is how it's done and this is how it's done. And I've been taught by my master, and I teach my student the same way my master taught. Anyway, the point is, it becomes very hard to be disruptive from inside the system. That's why Einstein was a patent clerk. He had a PhD, he had a doctorate in physics, but he didn't get a teaching position because he was not speaking the same language as everybody else. He thought things were not right. So unless we become very lucky by having someone who is able to translate the gap. So we're talking as poets. I don't have a technical background. I love science and mathematics, and I'm interested, and I have a strong imagination, and I can envision the poetic side. I can see the patterns. I can detect. I have the same access to all the same information everybody else does of the people who have come before us. It's like Goodwill Hunting, right? What does he say? He's like, when he's in the bar with the guy who's quoting all the history facts and stuff, and he quotes him back, he's like, I could get the same education as you for a library card and $10 of late fees.
Yeah.
Right?
Yeah.
And if we presume as the foundation level, we do not have it figured out. If I take that's how I start. It is not figured out yet. We don't understand it all. And anybody who's stuck doing it the same way, meaning the Big Bang is the thing, there's the inflationary model and all the rest of it, all this other stuff, we will never find the truth. If everybody sticks on the piece of ground that is, we know the truth today, we can't move to the real piece of ground, the higher ground, where there's a higher understanding of what's really happening. And I could be wrong, obviously. I'm not saying I have any absolute truth here. I'm just saying the harder we hold on to this branch as a monkey, the harder it is to let go and grab the next branch in the tree.
Yeah, well said. I like that. And it does bring a lot of movie quotes to mind, but the one that I like to share often is this movie, 3,000 Years of Longing. Really great scene about, how would humans explain the changing of seasons and the rising and setting of the sun if they didn't know they were on a rotating sphere orbiting, this huge star. Come up with mythology. They would, they would come up with stories to explain this stuff, and this, it's all encapsulated really great in this line where this main character says, mythology is what we knew then, science is what we know so far. And I'm very intrigued by the writing of that it's not science is what we know now. Science is the truth. Science is what we know so far. Tomorrow we'll know something more.
Well, it stabilizes. It stabilizes, which is nice. You want to have a stable foundation, but it also calcifies and becomes brittle. And so science progresses not in graduations, but in giant starts and stops. It's not an easy thing that just kind of spectrum slow. Yeah, it's like something massive, pun intended, massive will happen.
Thank you for intending the pun, by the way. It's very fun. Anyway, go.
We could just do this all day, by the way. But anyway, massive starts and stops where people have shifts of belief. And by the way, it goes both ways. So we're back again. Let's hammer this dead horse to smithereens. Flat earthers. You'd think you'd go past a point and never go backwards again, but that doesn't happen either.
Yeah.
We burn libraries in the past. They've burned libraries. We've gone there's Roman roads that were under the ground of barbarians for 1,000 years who couldn't make a road. There was high-tech aqueducts buried under volcanic ash that weren't recreated for thousands of years. So there is definitely opportunity to regress as well as progress. It oscillates all over the place.
Yeah.
And so we're in this fixture right now where we have this new thing, which is technology. And I think technology confers authority to those who provide technology to the people who don't know how to make technology. And so technology is the calcification of the status quo. Because I can't make a cell phone. Can you make a cell phone? So who am I to argue? I should shut the fuck up and sit down. I'm just a guy who reads books and listens to podcasts and has an imagination.
Yeah.
Okay. But perhaps we go back to Newton, we go back to Einstein, we go back to Pythagoras, we go back to Socrates, they didn't have cell phones. They didn't have Google, they didn't have AI. They just made shit up. and kept on going. So I like that quote of the mythology of the past, and we have something today we call truth. Tomorrow they'll look back on us and laugh.
Right. Yeah.
Well, and I'm not to make light of scientists. I have utmost respect for the people in their fields, but you look at what physics kind of is today, and we're still smashing together rocks. You know, we've got particle accelerators that are smashing tiny rocks together to see what comes out. And then the other side of it, we have cosmologists who are using telescopes to see how the universe smashes rocks together. You know, like we're kind of only looking at
Rock
two major
smashing.
sides, yeah, that are kind of the same side of the coin. You know, like there's more to it. There
Yeah.
is, and I think it kind of wanders into the woo a little bit, and that's you're not allowed to be a scientist that has ideas that are not provable, and we just don't have the tools to prove some of this stuff yet.
Yeah.
Whether it's the math, whether it's the way we measure things, we're not there yet.
Yeah. So here's a question, like, because I'm a proponent of that, like, not yet, but maybe the other side of the argument is like maybe we aren't capable ever. I just
I don't believe
I
that.
yeah, I don't either, because I just think it's just part of my essence of my being. Like sometimes I really think it comes down to like it's just more helpful for my body to think optimistically about stuff. This is I'll be real brief here, but there's a really fascinating psychologist named Gabor Mate, and he wrote this book called The Myth of Normal, and it's one of the coolest things. I haven't finished it yet, but one of my favorite things is he footnotes references. He quotes people, but then there's footnotes, and I just haven't seen that in a lot of those kinds of books. So major kudos to this guy. But he does talk about how impactful thought patterns, and there was a study that was done, and I think the title of the study was most people who have ASL, I believe that's the same thing as Lou Gehrig's disease, but I could be wrong, and I can't remember what ASL stands for, but it's one of those muscle diseases. The title of this paper was most people that have that are usually really nice people, which sounds weird, but he extrapolates on that, and it's not. It's a little misleading, almost clickbaity. But what he's talking about is anger suppression. There's lots of evidence that shows anger suppression is like very damaging to the body and can cause these like chronic illnesses and things. It's really, really fascinating. So at a base level, sometimes I think like, yeah, it's just more helpful for me to be optimistic. Anyway.
That's fascinating. Can I throw something in there real quick, John?
Yeah, for sure.
I looked at it when you said that. I looked at it the other way. I think I look at it from the point of view that, and I'm not going to go deep. We got to have to do a podcast one of these days, but I'm gonna cliff note this thing. I thought I was very independent once upon a time. I thought I knew that I was making my own choices once upon a time. Without going into depth today, because there's not the time or the place, but I learned something about my father that was hidden from me after he died. And it explained so much in that we had very common patterns of behavior. And you look at twins separated at birth.
Right.
You look at Helen Keller and another woman who described her likeness with Helen Keller in modern times, if you will, and she is also vision and hearing impaired, and the amount of similarities based on how one feels is profound. So when you said the Lou Gehrig's disease sufferers, they share something in common, but then you expressed it as a cause as opposed to effect. it struck me profoundly. I see it as an effect. I see being kind as an effect. And I know it's a progressively degenerative disease, so maybe it doesn't track. But I see it as when you become powerless, your strategy changes. You feel different. Maybe anger is not what you feel. Maybe if you see the future in different eyes, there's a commonality of behavior, an outcome, because they're all sharing a similarity in how it feels to be someone with that condition.
Mm. Wow. And I mean, yeah. I feel like we should wrangle this back to you, otherwise we're just going to keep talking all day. But the last thing I'll say about it, when we do talk, yeah, I totally agree. We'll do an episode about these kinds of things, and one of the core components of all these things that we're starting to dance around is empathy. Very fascinating concept to me. So I think we'll really be able to dive deep into this concept of what it means to empathize with somebody and be empathetic, and really fascinating stuff. So yeah, real quick, ALS, amyotrophic lateral sclerosis. So anyway, cool. Wow. Yeah, we're a bit over, but I didn't want to stop us. But thanks for letting me go on that little tangent about Gabor Mate. But yeah, just to bring it back, any final words here on the three-body solution?
I'm just going to say I do think it is potentially falsifiable, which is an important component. I think things like the multiverse, I don't even know how one would begin to falsify that as a hypothesis or theory. The inflation period and singularities. A lot of these things I think are equally, if not more, woo than what I've been talking about. So the things that I would say, falsifiability, and then predictions. So what is science? It's the ability to make predictions in natural laws. So I do see some predictive capabilities, number one, in being able to solve the three-body problem. If this is what I say it is, there should be, I'm saying it's not impossible. I'm saying it's not chaotic in the way of impossible to decipher. There is no rhyme or reason. There's no meaning. I'm saying there is a meaning. It has to do with the gravitational constant and the curvature of space-time and the way three objects interact amongst these physical realities. So it should be absolutely testable. I do think the gravitational constant would be testable, meaning my theory of the gravitational constant would be testable hypothesis, in that throughout the universe, we should be able to uncover different areas that are relatively different distances to the gravitational constant, and that could be observable. And secondarily, creating hollow spheres and testing the effects of the force of gravity within them, I think it may not be completely definitive, but what we should find is that the additive effect of adding more shells, representations of the gravitational constant, the mass shell itself, we could then predict that the experiments inside would essentially weaken the effects of gravity. So, like, everybody go back real quick to the four fundamental forces. We have strong, weak nuclear force, electromagnetism, and gravity in that order. And the gravity is so much weaker than the other three. It's preposterous. And I'm saying it's not. It's in line with the other three. And it's just the counter effect of the gravitational constant's, counterpole, the gravitational hill, if you will, that is suppressing the true power of mass 1 times mass 2 over distance squared. So if we could then make a shell, some kind of significant massive shell, like hollow out the moon or something, I'm not saying literally, but some kind of analog to that, maybe a computer model. I don't know. Whoever's listening to this who can model these things, have they modeled putting, masses inside of other masses, as opposed to just how they work, one to another without being inside a massive body. I think there is definitely, so to Tucker's point, woo, I'll grant woo. I'll say yes. I mean, it's way outside normal. So from being outside of normal, meaning, standard model, it is definitely woo. being woo in the sense of you can never prove or even come close to reaching another dimension, Bob. What are you talking about? Okay, I get that. The math side is mathematically accurate, I believe, but math doesn't necessarily have any connection to reality. I mean, it doesn't necessarily have a direct, even if the math works, if you will, like making a graph in this way and having quadrants and oscillations and whatever, yeah, I can make it work on paper or whatever, but it doesn't mean it ties to reality at all. But math, in certain regards, does tie to reality. We use it as a tool. It's very powerful, but not in all instances. And this is a big critique of string theory, is that it's mathematically beautiful. And by the way, physics has been stuck on string theory since like the 80s, late 70s, without progress. So the university system has not progressed really in pure science because, like Tucker was saying, they're just smashing rocks together. So the thing that is changing is the mathematics of physics. But how do you then, like the string theory is little vibrating strings. All right, good luck. Go find them. Nobody has them. It's really hard to do. So anyway, and it takes 10 dimensions to do it. So there you go. I mean, we're back to the beginning again. And I think that's my point, is at least what I'm saying, I believe, has physical roots, like physical, measurable roots, as opposed to what I'm really against, which are singularities and inflation fields. So I think the inflation field model of the expansion of the early universe and a singularity are poppycock and multiverse, because you need the multiverse to go hand in hand with inflation. And then you have this concept of finely tuned. Like, why are we so finely tuned that we are all of our natural laws are such that we have what we have? There's no rhyme or reason to it other than the multiverse. And we're in one of the multiverses that it has a stable regime of, constants and physical laws that allow for things like, matter and energy to exist, etc. So there's like lots of woo out there, is my point. Like in the real science, quote unquote, real science today, actual PhD scientists are like vastly woo, in my opinion, right now.
Gotcha. Yeah. Yeah. It's, like I said earlier, like a lot of it does kind of, the specificity of it kind of goes over my head. It just, I don't have the background. So it's like, on one hand, I there's no harm in me like taking your word for it. Okay. Like, yeah, I can appreciate this possibility. I don't have a reason to just say like, no, you're wrong. You know what I mean? That wouldn't be helpful. That would be the Dunning-Kruger effect in effect, maybe.
But maybe I'm in there too. So that, I mean, I definitely
potentially,
I hold that with deep regard. So I'm not at the end, I'm at the beginning, I would say, but maybe it's a bright beginning. If I'm in the ignorant area of that curve, but I've already got the ideas, like maybe I have a long way to go to make it concrete enough to ever be taken seriously. But maybe, being where I'm at with an idea, like a poetically beautiful idea, metaphorically powerful idea, but in the ignorant stage, maybe that bodes well for my future, if you get my point.
Yeah. And I think it's, kudos to you for just being able to admit that and say like, this could be falsified. It's not like I would say that's much more of an intellectual take than a personal take, to be able to detach yourself from the concept of being right or wrong.
Well, let me be really clear here. I expect, and this is beyond egotistical even to mention, but I expect no rewards, no accolades. I don't care if anybody knows my name. I don't care if it's true or not in a personal sense. It's an obsession of imagination and like the poetic side, the beauty of it. It's just, I'm obsessed by the beauty. The beauty attracts me to such a level that I've thought about these ideas for hundreds and thousands of hours.
Yeah.
And it consumes me, but not for credit or recognition. I love my life. I love being anonymous. I love my family and I love my friends. I love you guys. I love walking. I love eating. I love playing. I love sunshine and winter. I just don't give a shit. I don't give a rat's ass about any prizes or accolades or status or any of that. And so, but maybe that's the magic sauce that allows someone to think outside the box and move
Yeah.
the thing forward for all of us, like we're talking about our
Right.
lifetime. I really don't know. It could be 1,000 lifetimes. I don't know. I just don't care. It means nothing.
Yeah. Well said.
Yeah, no, same boat. I'm not trying to figure out the secrets of the universe because I want to be known for it. I do it because it's the way my fucking brain's wired. I can't not do it.
Yeah.
So how do you take credit for that? That's exactly
Yeah.
my point. It's like a retriever bringing the ball back to you.
Yeah,
Like
that's just
It's
what I was built to do.
it's what I'm built to do. I'm obsessing over this one thing because I obsess over beautiful ideas, and it makes me happy to do so. But I'm not trying to say I am consciously creative in that way. It's letting go, and I've learned this later in life. Trying to be consciously pick, like try to write a hit song, right? Good luck. It just
Mhm.
happens, when you let it go and you have the right group and the right time and the right influences and all
The very
things.
center is
That's it.
vibing.
Yeah.
It's
Then the thing
cooking.
happens. Then it emerges from
Yeah.
the soup of all these things that are way outside your control.
Right. And I appreciate that. I again, same. I agree. I feel like I'm in the same boat. This is just kind of so fascinating and curious to me. We did make a choice to record this, put it out there, but not for this like recognition thing. This is the third podcast I've done. Nobody listened to the other two. Do you know what I mean? Like, it was just like, I'm so interested in this, and
I'll tell you, my
and
life is better for it, though. My life is way better for it. Since we started doing this, gentlemen, I've self-improved. I'll echo what Tucker was saying. My intellectual stimulation off the charts. I look forward to our time conversing. Recording it and putting it out there, I think it helps, but it's not that's why I'm not
Yeah.
doing it. That's not why I'm doing it. It's an added seasoning to the sauce.
Yeah, exactly. Seasoning. Yeah, it's another ingredient that just like keeps that berry center nice and ripe,
Totally. No, I think it makes it real. There's like a little edge to it because it is
Mhm.
going to go out there. Now, the flip side of that is nobody listens, perhaps, and then whatever.
Well,
But
think of it this way, though. If, say, 50 years from now, barring any major disruptions to humanity, what if somebody does prove your theory? But by then, we'll have an AI that goes, nah, no. Bob did that on episode 23 back in 2024.
Right.
And he had the idea, you just proved it.
Yeah.
Well, to that point, I'll call back one thing that John, you had mentioned episodes ago, was that it was at Babylon or the Tower of Babel. I'm trying to remember that guy who created
The library of Babel.
Thank you, the Library of Babel. That really struck a chord with me. In that, here's the point: like, fuck originality, man. It doesn't matter. Like accreditation of this stuff, someone can AI or create every single song variable, right? All the notes together, all the chords, progressions, everything could be done in advance. And so what?
Yeah.
Right? Like it really doesn't matter. So ultimately, my life is finite. Assuming they don't put me into an AI computer and I have to live eternity in some program of some software program or something. But assuming
have to or get to. Oh.
No,
it would be a have to, I think, for me.
Yeah,
exactly. But I think the point is, we're so finite. It's the journey, not the destination. And if someone in 550 years, 500 years ever, scan the sum total, like an archaeologist, let's say, finds our like a digital archaeologist in the future finds our podcast and says, wow, these guys figured this way back in 2024. This is like 3034 or whatever.
Right.
What difference does that make to me?
Yeah.
Exactly.
What difference? It would make none. I would never know. I would never even. So I don't even consider it. It's not even on my radar. It's literally. I'm glad you brought it up because I think it's important to discuss. In that people can get consumed by dark side, if you will, the metaphorical dark side of recognition and
like you said, status and
and that's a dark place to go. I think that becomes consciousness, and in fact, it's a block. So the only time I've ever blocked my creativity is when I think about how to use it for personal gain. As soon as I begin, if I ever, and I have in the past, but I don't anymore because I know how fruitless it is, eventually all your imagination just goes into future scenario building of your fame and fortune and status, and all the things that were beautiful disappear. Like, you don't get the beautiful anymore. You just get these visions of self-aggrandizing scenario. And those are just hollow and meaningless and empty. Friends, family, experience. That's what is meaningful to me, and I hope most of our listeners. The curiosity, openness to grow, change, all these things that we live in, not us as a team here. That's the good stuff, man. That's the good stuff.
I think we're definitely have to wrap up, or else we'll just keep talking. But I think this time, because I was going to share this quote earlier, but I didn't. But I think I'd like to close, atypical of the normal one, which I love the quote about, you'll never be alone with a poet in your pocket. So it's so perfect for this podcast. Literally sending poets on a phone in your pocket. It's like, did John Adams know that we were going to do this? Probably not, right? But but I love it. But so I have another quote I'm going to end with. But for now, I will say I don't know what we're going to do next week. We'll figure that out. Yes, if you're listening, thank you. Get a hold of us. Let us know what you think. sendingpoets@gmail.com. Feel free to leave a review wherever you're listening. But until next week, check this quote out, you guys. Learners inherit the earth, while the already learned are beautifully equipped to deal with a world that no longer exists.
Wow.
And that's Eric Hoffer.